Kirkman. All right, ladies and gentlemen, here we are starting our Module 8, which is all about percents. Our first video here is going to be about how to model a percent. Now, if you've joined us in class, you may have seen us do a modeling already by creating the letter D for dipole and on a hundreds grid, and talk a little bit about how a percent comes from the Latin word percentium, which means out of 100. And so we should know that percents are always out of 100. So in this lesson, we're going to identify a percent based on a model. We're going to convert between percents and decimals using a model as well. All right, so in our notes, get my pen up here, we're going to write down, so a percent is a part to whole ratio. So it is a ratio where we are comparing part to whole, where the whole is always 100. So just like we said how percentages are out of 100, it's always going to be something out of 100. So you can see here, part to whole is our ratio, and what the ratio we're comparing is out of 100. All right. Each percent can also be modeled by a 10 by 10 grid, which would have 100 squares in it, and it can be written as a ratio in fraction form. So here you're going to go ahead and see an example. 78% is the same as the ratio 78 out of 100, which I can read as 78 hundredths. And then if you can read 78 hundredths, then you can write it as a decimal, which is 0.78. So in the beginning, we're just going to practice a couple of these models of percent. So we're going to take the percent that's given to us. We are going to shade in the hundreds grid to match, and then we are going to write the ratio out of 100. So in this first one, we have 50%. So we're going to go ahead and color in 50% of 100, which you should know is half. And half of 100 is going to be 50. So we're actually going to color in 50 squares. Because this is a 10 by 10 grid, every row that you see is 10. So all I had to do was color in 1, 2, 3, 4, 5 rows. And that's going to get me my 50%. Now down here, writing it as a ratio, part to whole, we know that the part is 50 because we shaded in 50. And the whole is going to be 100. Now we're going to do that again with 35. So because when I shaded 50%, I colored in 50 squares, you should realize that when I shade 35%, I'm going to shade in 35 squares. So I'm going to take 3 rows of 10. So that's 2, 3. And then I'm going to shade in 5 individual squares. 1, 2, 3, 4, 5. So that is representing 35%. Then if I'm going to write here, our part to whole, we had 35 shaded in out of 100 total. Then with our last one, we have 10%. So same thing, 10% is just going to be 10 out of 100. So when I write my ratio, I'm going to write 10 out of 100. And you can see right here that we have 3 representations of percents. Here we have the actual percentage written. Then we have a visual model out on a 10 by 10 grid. And then finally we have our ratio written out in fraction form. All right, so now we're going to use this information and the model here on the right to answer the questions below. So the first question says, how many squares are shaded? Well, I know that there are 10 here in this row, 10 in this row, and these boxes are 5. So that means that I have 25 shaded squares. What is the ratio of shaded squares to total squares? Well, because it's a 10 by 10 square, we know that the total is 100. How could you represent the shaded squares in a percent? Just like we did in our last one, we know that our percentage, which is out of 100, that means we're just going to take that numerator to write as a percent. So as long as that ratio is out of 100, we can just take the numerator. So this turns into 25%. Now for question D, it says if the shaded squares represent 25%, which they do, then what percent do the unshaded squares represent, the white ones? Well, I could count them all, but I know that there's 100 squares in that big box. I know that 25 of them are shaded. So therefore, 75 of the squares are unshaded. That means that 75 out of 100 are not shaded, which turns into 75%. There you go. On this next part, because you saw up here that we were able to go from a percent to a ratio to a decimal. So on this next part, we are going to go ahead and convert between percents and decimals. There you go. So a percent can be written over 100 because that's what percent means, and then read out loud. So 45% would be written as 45 over 100, which is read as 45 hundredths. Now, if you know anything about decimals, 45 hundredths written in decimal format would be 0.45. Now, if you're struggling with that, you can also go ahead and just move those decimal points. Basically, a percent can be divided by 100. That's basically what this means, because remember, this is a division bar. So we're going to do 45 divided by 100, which is the same as moving the decimal to, oops, I don't want to, oh, let's do it again. 2 places to the left. So as a review, when I divide by 10, I move left. And when I multiply by 10, I move right. So that's a good thing to remember. I'd write that down somewhere because that is always true, and you can use that in a lot of situations. So here in our example, I have 45%. My decimal point is normally right here at the end of that 45. It's a ghost decimal point, which means you don't always see it, but it's there. And because I want to turn a percent into a decimal, I'm going to go ahead and divide by 100. So I'm going to move it 2 places to the left to get 0.45 or 45 hundredths. Same thing here. I'm going to move my decimal point 2 places to the left for 87% and get 0.87 or 87 hundredths. Then here on 150%, I'm going to move it 2 places to the left, which is why our decimal point goes between the 1 and a 5, and you get 1.5. Now this example I think is the most important to pay attention to, because when we look at these first 2 examples, they seem really nice and simple, and some students can get confused and just put the decimal point in front of the percentage, but that is not the case. If you have a percentage that is over 100, you want to make sure that you're only moving it 2 places to the left so that you get a whole number in your decimal answer. All right, so go ahead and pause the video here and do the practice problems below. Here you're turning percents into decimals, but down here you're going to turn a decimal into a percentage. So you're going to have to do some thinking and maybe remember about our notes over here to figure out how to do that. But go ahead and try it on your own and then join me to see if you get it right. Awesome. So if you've paused our video, you should have had 0.70 for number 2, 0.16 for number 3, and 0.37 for number 4. Excuse me. For number 5, because we are turning the decimals, we're basically going the opposite direction, decimal into percent. We're going to do the opposite sign, and we're going to multiply our decimal by 100 to get our percentage, which means I'm moving my decimal to the right. So I'm going to move it 2 places to the right to get 28%, 2 places to the right to get 62%, and 2 places to the right to get 90%. All right, now that you have that down, we're going to go ahead and fill in these missing representations. You have learned all 4 representations. You have your visual model, you have your ratio, your percent, and your decimal. So each of these examples is going to give you one of the representations, and you have to fill in the missing ones. So let's start with the first one. We know that there's 1, 2, 3 rows, which means that is 30 squares shaded out of 100. Okay, we also know that that would mean that that's 30%. And then in the end, that means my decimal is going to be 0.30 or 30 hundredths. In the next example, they give us the percentage already, 75%, which is awesome. We can turn that immediately into a decimal, 0.75, and we can identify how many parts are going to be shaded in this model, 75 out of 100. Grab something to color with, and we are shading 75. So I'm going to do 1 column or row, 2 rows, 3 rows, 4. We're going to basically do all of them but 3. There we go. And then we're going to add in 5 more. So that was 70. 1, 2, 3, 4, 5. And there we go. We now have our visual representation. Now in our next example, it already gives us the ratio of 45 out of 100. So I know that I'm going to be coloring 45. So we'll do this a little faster. 1, 2, 3, 4, and then 5, 5. And then down here, we're going to write our representation. So 45 out of 100 is 45%, which does turn into 0.45 or 45 hundredths. Awesome. This last example may not be in your notes, but I'm sure that you can figure it out with me. Todd wrote the statement below, but he made an error. We need to describe his mistake and correct his work. He said that 50% is the same as 5.0. What error did he make? What did he do wrong? Well, as we learned before, percentages are out of 100. So 50% is the same thing as 50 out of 100. Okay? Then, if I'm going to read this fraction, that's going to be 50 hundredths. And 50 hundredths in decimal form is going to be 0.50. So what did Todd do wrong? Well, he didn't move his decimal over enough spaces. He only moved it over 1 space to the left. He needed to move the decimal 2 spaces to the left. And that is what Todd did wrong. All right, join us next time to learn more about our decimals. Bye.